0-day brief.
Imagine for a second that you're paying top dollar for, like this elite enterprise-grade security team to guard your data center.
Right, the absolute best you can buy.
Exactly. You trust them completely because, well, they're the premium option. But then you find out they left a back door wide open. And not because of some highly sophisticated nation-state breach, but because they literally wired a critical high-voltage access panel directly into a public lobby light switch.
Oh, man.
Yeah. Anyone who wanders in and flips that switch just gets full, unrestricted control of your entire infrastructure.
Which is terrifying.
It really is. And that is the reality playing out right now on millions of servers.
So, welcome to the Deep Dive. I'm your host, and today we are tearing apart CVE-2026-48172.
That's a mouthful, but a really important one.
For sure. This is a CVSS 9.8 critical vulnerability found in the LiteSpeed cPanel plugin. And for anyone managing infrastructure out there, you know that a 9.8 means the house is actively on fire.
Yeah, it's about as bad as it gets.
Yeah.
It's an unauthenticated, network exploitable bug that just hands attackers full kernel access. It's actively being exploited in the wild as we speak, and federal agencies have actually been slapped with this super strict 4-day deadline, May 29, to completely rip it out of their environments.
And to really fully grasp the severity of that 9.8 rating, we have to contextualize what LiteSpeed actually represents in the deployment stack.
Right, because it's not just some random tool.
Exactly. In the web hosting ecosystem, LiteSpeed isn't some fringe experimental package you download from a forum. It is widely regarded as the gold standard Apache alternative for cPanel environments.
So people are paying good money for this.
Oh, absolutely. Providers deploy it specifically because it's a premium enterprise-grade product. It's engineered for high performance. It signals quality to their customers.
But that's kind of the trap, isn't it?
It is. That premium reputation is exactly what makes this vulnerability so insidious. I mean, we aren't just looking at a sloppy piece of code here. We are looking at the catastrophic consequences of blind trust in the third-party software supply chain.
Okay, let's unpack this. I want to drill down into the actual mechanics of the exploit, because we know the vulnerability lives inside a really specific function in the LiteSpeed plugin. What was it called again?
It's called lsws.redisAble.
Right, redisable, which on paper sounds completely trivial. Like it's just designed to toggle Redis caching on or off within the cPanel admin interface.
Yeah, a simple on-off switch.
So how does a mundane caching toggle escalate into a 9.8 critical meltdown? I mean, walk me through that execution chain.
Well, it starts with the cPanel JSON API. And this API is designed to expose administrative and user functions over HTTP.
Okay.
So when a standard user authenticates to their basic low-level cPanel account, like just a regular user, they receive a session token.
Right.
They can then construct an HTTP POC request, or honestly, even just a simple curl command directed right at the cPanel JSON NAPI RedisAble endpoint.
Wait, so just a normal web request?
Just a standard web request. The cPanel core receives it, identifies that it's destined for the LiteSpeed plugin, and just passes the payload off to the plugin's backend binary.
And this is where the structural failure actually happens, right? Because the vulnerability is classified as CVE-2026, which is incorrect privilege assignment.
Exactly.
Meaning the cPanel API just doesn't even verify if the user's an administrator before passing that payload along.
The API effectively delegates all the authorization checks to the plugin itself. It just assumes the LiteSpeed binary will say, hold on, does this specific user actually have the authority to manage system services?
But it doesn't do that.
No. The lsws.redisAble function completely lacks that critical check. It simply accepts whatever input it gets and proceeds to construct a system command to start or stop the Redis daemon.
Let's ground this in like a systems architecture concept for a second. Because this isn't just finding a forgotten master key in a building lobby.
No, it's way worse.
It's more akin to giving a user space application direct memory access because you blindly assumed only the operating system would ever call that specific function. You have an API endpoint exposed to regular, completely unprivileged cPanel users, and it maps directly to a root-level bash execution.
That is an incredibly accurate way to frame it. Because the LiteSpeed plugin daemon itself runs as root, any system command it spawns also runs as root.
Wow.
Right. So if an attacker crafts their curl request to include, say, shell metacharacters like a semicolon followed by a reverse shell payload, the plugin just blindly concatenates that malicious input into the system command.
And just runs it.
And executes it as root. What's fascinating here is that the attackers aren't actually trying to manage Redis caching at all.
Right, Redis is completely irrelevant to them.
Redis is just the camouflage. The missing permission check turns a simple toggle into a completely unauthenticated root execution primitive.
Here's where it gets really interesting, though, because the ease of that execution is what makes the environment it operates in so dangerous. We really need to talk about the blast radius here.
Oh, the blast radius is massive.
Yeah, because these plugins are primarily deployed in shared hosting environments. And for you, the listener managing these stacks, you know the business model relies heavily on hyperdensity.
Exactly. Packing as much as you can onto one machine.
You've got one physical bare metal server hosting hundreds, sometimes thousands, of completely isolated tenant accounts. You might literally have a sprawling enterprise e-commerce database sitting on the exact same physical disk as a $5 a month hobby blog about, I don't know, knitting.
Yeah, and the entire security model of that shared environment hinges on strict virtualization and permission sandboxing.
Right.
The hobby blog gets its own user space, its own database limits, its own file system quota. The knitting blogger cannot traverse directories to go view the e-commerce site's sensitive files.
They're boxed in.
Right, they're boxed in. But when you achieve root execution through this LiteSpeed API flaw, that entire permission boundary just evaporates instantly.
Which brings up a critical architectural question that I think a lot of people are asking right now. If we know that a single flawed endpoint in a third-party plugin can compromise the entire bare metal server, why is cPanel allowing plugins to run as root in the first place?
That's the million-dollar question.
Like, if the industry knows third-party code is inherently risky, why not run these plugins in a restricted namespace, like an isolated container, and just deny default root access from the jump?
I mean, it's a very compelling argument on paper, but it hits a massive wall when you look at the actual operational requirements of the software.
How so?
Well, think about what a web server plugin actually does. To function at all, LiteSpeed has to bind to privileged ports like port 80 and 443.
Sure, for HTTP and HTTPS.
Exactly. And it has to modify system-wide configuration files in the etc. directory. It has to provision TLS certificates, restart network daemons, manage DNS zones.
So it needs deep access.
It needs it.
Yeah.
These are, by definition, kernel-level and root-level operations. If you place the plugin in an unprivileged namespace, you completely break its core utility. It just wouldn't work.
Okay, so the architecture doesn't grant root access out of sheer laziness.
No, it grants it out of operational necessity.
Got it. So the fundamental design flaw isn't the existence of root access itself, it's the mechanism of authorization.
Yes, exactly.
It's the difference between a zero-trust model that verifies identity at every single gateway and a model that simply hands over the keys to anyone who happens to know the URL.
Precisely. And, the impact of that architectural choice becomes incredibly clear when you compare this to another recent cPanel vulnerability. Let's look at CVE 2026-484D.
Oh, right. The one from earlier this year.
Yeah. That was a bug found in cPanel's own proprietary code, and it allowed an unprivileged user to escalate their permissions and become a cPanel administrator.
Okay, so they sound kind of similar on the surface, right? Both are privilege escalations stemming from authorization failures.
They are, but the resulting damage is vastly different.
Walk me through the difference. Because an admin escalation is bad. It means the attacker has panel access, they can modify virtual hosts, hijack domains, alter configurations for other tenants.
Sure, it's a bad day.
Right, but they are still theoretically bound by the hypervisor or the operating system's kernel limitations, aren't they?
They are, and that's the key. Root access obliterates those limitations entirely. When you exploit the LiteSpeed bug and gain root, you aren't just an admin in the control panel. You own the underlying metal.
You have the keys to the entire kingdom.
Everything. An attacker with root can use system tools to dump the live memory of the machine. They can extract plaintext passwords directly from RAM before they're even hashed.
That's terrifying.
It gets worse. They can steal every single SSL private key on the server, which allows them to silently decrypt the web traffic of every single hosted tenant.
So even secure transactions are compromised.
Absolutely. They can bypass MySQL permissions entirely just by directly reading the raw database files off the disk. They can drop persistent kernel-level backdoors that survive reboots and completely evade standard antivirus scans.
So an admin compromise ruins a handful of websites.
Yeah, but a root compromise means you literally have to scorch the earth and rebuild the physical machine from scratch.
And it only takes one tenant one compromise $5 hobby blog running a single script to trigger that scorched earth scenario.
Just one.
This kind of forces us to look beyond just the developer who forgot to write an if statement.
We have to.
We have to analyze the broader ecosystem that allowed a 9.8 critical vulnerability to sit completely undetected in premium software for who knows how long. And I know you refer to this phenomenon as the plugin trust paradox.
I do. If we connect this to the bigger picture, the plugin trust paradox is this systemic psychological blind spot within enterprise IT.
How does it work?
Well, when massive hosting providers or managed service providers conduct rigorous security audits of their infrastructure stacks, they allocate their resources toward the most obvious targets.
Like the core systems.
Exactly. They meticulously audit the Linux kernel for privilege escalations. They audit the Apache core. They audit cPanel's base code. But when they get to a premium enterprise-grade plugin like LiteSpeed, the scrutiny just stops.
Because it's expensive, right? And expense implies security. I mean, the procurement process almost creates a false sense of safety.
It really does.
The logic sort of dictates that if you are paying thousands of dollars for a premium enterprise license, the vendor must have already done the rigorous code auditing for you.
And that assumption is incredibly dangerous. Because the paradox dictates that the more reputable and widely adopted a premium vendor becomes, the less independent scrutiny their compiled code actually receives from the broader security community.
Because everyone just assumes someone else already checked it.
Exactly. Because no one's actively hunting for bugs in the good software. A vulnerability as rudimentary as a missing permission check on a caching toggle can just survive in production environments for years.
I want to pose a structural dilemma regarding this paradox, though, because we have two ways to assign fault here.
Okay, let's hear it.
On one side of the argument, you could say this is entirely LiteSpeed's failure.
Right.
Their developers made a rookie command injection mistake. They completely failed their internal QA process. They patched it in version 2.4.5, and they own all the blame.
Sure, that's a valid perspective.
But on the other side, isn't this really a catastrophic failure of cPanel's API design? Like, they built a plugin architecture that grants root execution by default, but relies on this decentralized honor system authorization model, where every single third-party developer has to manually remember to write their own access checks.
Right.
Where do you land on that spectrum? Who's really at fault?
I lean heavily toward it being a failure of API architecture.
Really? Even with the missing code?
Yes, because human error in software engineering is a statistical certainty.
Fair point.
Developers are going to make mistakes. They're going to leave debugging endpoints exposed, or they'll forget an authorization flag on some minor feature update. If cPanel's API architecture expects every single external plugin to flawlessly manage its own permissions at the application logic layer, they have designed a system that is mathematically guaranteed to fail.
You're saying the authorization should be completely decoupled from the plugin entirely?
100%. The cPanel API gateway should act as the absolute source of truth. Before a web request is ever even passed to the LiteSpeed binary, the API gateway should verify the user's session token against a strict role-based access control matrix.
And if they aren't an admin?
If the user isn't an admin, the API should drop the request immediately. The plugin shouldn't even know the request happened. Relying on the plugin to police itself is a fundamental violation of defense in depth principles.
So what does this all mean for the people managing these systems right now? Let's shift our focus to the operational reality on the ground, because this timeline is incredibly aggressive.
It's basically a sprint.
Yeah. The vulnerability was discovered by a security researcher named David Strydom, and within just 5 days of the public disclosure, CISA, the Cybersecurity and Infrastructure Security Agency, added CVE-2026-48172 to their known exploited vulnerabilities catalog.
That happened on May 26th.
Right, May 26th, and they issued a federal mandate to patch it by May 29.
Which is wild. That timeline is literally the loudest alarm bell the security community has.
A 3-day window to patch.
Yeah, CISA does not issue 4-day remediation mandates for theoretical proof-of-concept vulnerabilities. They issue those mandates because they are observing active, widespread exploitation in the wild.
So it's happening right now.
Yesterday's quiet disclosure is today's automated attack campaign. Attackers have already weaponized this curl payload, and they are actively scanning the entire internet for exposed cPanel instances.
I want to look at this from the perspective of a systems administrator who is staring down that May 29 deadline. Because a 4-day turnaround sounds simple if you're just like updating an app on your phone.
Sure, just hit update.
Right. But in a massive shared hosting environment, what does that actually look like operationally? You don't just click update on a bare metal server hosting 5,000 live e-commerce databases.
No, the operational friction is immense. When you are managing enterprise infrastructure, you are dealing with really rigid, highly complex dependency matrices.
It's never just one piece of software.
Never. To patch the LiteSpeed plugin to a secure version like 2.4.5 or 2.4.7, you might first be required to upgrade the entire web host manager, or WHM, to version 5.3.1.0 or higher.
And upgrading the core WHM platform is never a frictionless process.
It's a nightmare.
You risk breaking custom Apache modules, you might deprecate legacy PHP environments that your clients rely on, or even sever third-party billing integrations.
Exactly.
Right.
You are effectively forced to play a high-stakes game of operational roulette over a holiday weekend.
Yeah.
Under normal circumstances, an infrastructure team would take weeks to deploy a WHM upgrade. They'd test it in a staging environment, verify compatibility with all the tenant configurations, they'd schedule a maintenance window.
But they don't have weeks.
They have hours. With an actively exploited 9.8 vulnerability, you lose the luxury of staging. You have to force the patch into production immediately and just pray that your support queue doesn't light up with 1,000 offline tenants.
But the alternative is worse.
Much we.
If you don't patch, you're leaving the door wide open. But that actually brings us to a massive blind spot for the defenders trying to determine if they've already been compromised.
This raises an important question about visibility.
Right, because the visibility gap here is terrifying. If an attacker exploits this, they aren't dropping a massive, noisy malware binary on the disk that triggers an alert.
No, they are just sending a standard HTTP request to the cPanel API.
So from a logging perspective, the exploit looks nearly identical to legitimate administrative traffic.
Yep. If a hosting provider wants to find out if they are being targeted, they have to run a very specific command through their web access logs. They need to grep for the exact string cPanel JSON opfunc redisable.
Which is a fast search, sure.
It's fast, but the critical failure is that you have to actually know the endpoint exists to look for it.
And most security operations centers don't know the internal function names of every single third-party plugin they run.
They don't. And because they don't know what to look for, the attackers can operate with near impunity. The true attack surface isn't just the vulnerable code, it's the massive visibility gap where defenders are completely unaware of the pathways into their own systems.
Which brings us directly to you, the listener. If you are a customer renting space on a shared hosting plan, you are in an incredibly precarious position right now.
You're completely at their mercy.
You are. You do not have root access to the underlying server. You cannot SSH into the machine and manually upgrade the LiteSpeed or WHM binaries yourself. You likely don't even have the permissions to view the server logs to see if your specific node is being targeted. Your security is entirely dependent on the operational competence of your provider.
And this is exactly where active vendor management becomes your only defense.
What should they do?
You cannot passively assume your host has handled this. You need to open a priority ticket with your hosting provider today. You need to ask them explicitly if they are running the LiteSpeed plugin and if they have successfully deployed the patched versions.
And I'd say you should push them further. Ask them what their audit process looks like for third-party binaries. Because if their support team doesn't understand the severity of a CVSS 9.8 flaw, or, if they are delaying the patch due to dependency conflicts, they are actively gambling with your data.
Yep.
If they can't provide a confident, transparent answer, it is time to seriously consider migrating your infrastructure to a provider who actually understands the threat landscape.
The immediate technical fix is applying the patch, sure. But the long-term strategic solution requires customers holding their providers accountable for the entire software supply chain they choose to integrate into their stacks.
Okay, let's synthesize everything we've unpacked today. We started by examining a seemingly harmless feature, a Redis caching toggle, and exposed how a single missing authorization check turns a basic web request into a devastating root command injection.
A single line of missing code.
Unbelievable. We explored the architectural necessities that force these plugins to operate with kernel-level privileges, and why that makes cPanel's decentralized security model so incredibly dangerous. And finally, we highlighted the sheer operational nightmare of pushing untested patches to thousands of live servers under the pressure of a federal CISA deadline.
Before we wrap up, I want to leave you with one final structural thought regarding the economics of cybercrime here.
Oh, this is a great point.
We spent a lot of time today discussing the plugin trust paradox, the idea that the security industry implicitly trusts premium, expensive software to the point of neglecting basic audits. Attackers understand this paradox perfectly, and it is shifting their entire financial model.
They're following the path least resistant.
Exactly. Think about it. Why would a cybercriminal syndicate spend millions of dollars and months of elite research trying to find a zero-day vulnerability in the heavily guarded Linux kernel or like the iOS operating system?
It's too hard.
The return on investment simply isn't there anymore. Instead, they are realizing that the absolute cheapest, fastest path to total system dominance is to simply buy a $50 a month license for the most trusted, widely deployed, and critically unscrutinized enterprise plugins in the supply chain.
Wow.
They are literally weaponizing our own trust against us.
It completely inverts how we need to think about threat modeling. The most dangerous code on your server might not be the obscure open source script you forgot about. It might be the premium enterprise integration you paid top dollar for. Thank you for joining us for this deep dive. Stay curious, stay rigorous, and always question the security of the systems you rely on.
Thank you for listening to Zero Day Brief.